Hi everybody, welcome to Unit 3, Families of Functions. This unit will be a little different with the videos in that we'll be looking at this Elmo screen, which you can see here, to learn how to do some of the graphing we need for our transformations. So, you should be with your homework packets at home. Looks like this, I've just zoomed in for the graphs. And the whole deal with today is we're going to learn our parent graphs. And like I said in class, the parents are the basic graphs you need to be able to do everything else with. There are 7 of them, and you just think about basic points to plug in your head. Square a bunch of numbers, cube a bunch of numbers, whatever. And I'm going to go through that with you now. Keep in mind there will be pop quizzes, so as soon as tomorrow or the next day, I can hand you a sheet of graph paper and ask you to graph these without a calculator. The whole goal is that you can do all of this graphing in the end without your Inspire. The Inspire is for discovery only. So here we go. Our first parent, we're on our day 1 homework, is y equals x squared. And this one you know, you've seen this a lot before. And I just want to remind you how to draw an accurate, quick parent graph of the parabola. So you think about numbers. 0 squared is 0, so the first thing you plot is 0, 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And when you come to the negative x side, the same thing happens. When you square a negative, it goes positive. So negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. And hopefully that's not a big surprise. You've seen parabolas lots of times before. Connect with a nice smooth curve. And there you go. So there are 1, 2, 3, 4, 5, 6, 7 major points on a parabola that you need to be able to graph quickly and well and accurately. 0, 0 is what we call the vertex or anchor point. And we'll talk more about that as we go through this unit. Okay, so moving on to y equals x cubed, our second parent. We're going to do the same thing here. We're going to think about good numbers in our head and plot them. So if x is 0, 0 cubed is 0. 1 cubed, 1 times 1 times 1 is 1. And 2 cubed is 8. Remember, it's multiplication. 2 times 2 times 2 is 8, not 6. So you'll plot 2, 8. Now when you multiply 3 negative numbers, you get negatives. So negative 1 cubed, or negative 1 times negative 1 times negative 1 is negative 1. So we'll plot negative 1, negative 1. And negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. So there's our negative 2, negative 8. And we connect this with a nice smooth curve like we saw in class today. Okay, our third parent graph is the absolute value graph. Now this we saw in our prerequisite chapter, and you've seen this also in algebra classes, so another one that shouldn't be much of a surprise. Absolute value means distance from 0 on a real number line, so everything comes out positive. There's no such thing as a negative distance. 0, the absolute value of 0 is 0. The absolute value of 1 is 1. 2 is 2. 3, 3, 4, 4, and so on. In the negative direction, when I find distance, it's positive. So the absolute value of negative 1 is 1. Negative 2 is 2. Negative 3 is 3, and so on. And that's what we like to call our V. The absolute value parent graph looks like a V. So you'll take your straight edge and make a nice V. Okay, so keep in mind this has 0, 0 in it also called our anchor points. And going back to y equals x cubed, that also has an anchor point of 0, 0. So far we can see already that math is consistent. Just as I zoom out, the first 3 of my parent graphs have anchor points at 0, 0. And in fact, you'll see that almost all of them do. All right, so let's zoom in to the square root of x. And again, you know, it's the same idea. We're going to think about numbers. The square root of 0 is 0. There again, we have an anchor point of 0, 0. The square root of 1 is 1. Plot 1, 1. I do not know the square root of 2 or the square root of 3, so we skip that. We move to 4. The square root of 4 is 2, so I plot 4, 2. I don't know the square roots of 5, 6, 7, or 8, but I do know that the square root of 9 is 3. So I plot 9, 1, 2, 3. So with my square root parent, there are 4 major points to plot and know really well. And again, see, sometimes you miss a little, but as long as you made a big fat point where you meant to hit, it's fine. Okay, so those are our first 4 parent graphs. Again, you can see consistencies. Some of them you've seen before. They all have 0, 0 as their anchor point. Okay.